Okay, so today we are going to start looking at 2 by 2 systems. What that means, it is a system of linear equations. And a system of linear equations are basically two linear equations that interact in one of three ways. So we have our 1, 2, 3 different ways that those two lines can interact. The first way is if they just cross at a single point. So if you have line, oops, daisies. So if you have line, line, like that, they are going to intersect at a single point. And in that case, your solution will be an ordered pair x, y, wherever they cross. Sometimes lines don't cross at all. Sometimes you might have parallel lines that just run parallel to each other like that. And if that's the case, if our solution is where they cross, they never cross. So in this case, we would have no solution. And that's easy to see when you're graphing because you can graph them and you can see that they're parallel lines, so there's no solution. However, algebraically, if you do the work, you find if there's no solution, your last step is going to end up as an untrue statement, like 0 equals 2 or 5 equals 3, something that's not true. And then another way they can interact is sometimes when you write lines in different forms, like standard form and slope-intercept form, they end up being the same line. So you would graph the line and then graph another one on top of it, and it's the same line. In this case, there would be infinitely many solutions. So I'm going to abbreviate that, infinitely many solutions. So on a graph, if you graphed it, they'd be the same line. If you were doing it algebraically, which we're going to talk about, you'd end up with a true statement. Usually it's 0 equals 0, but it could be anything. 2 equals 2, 5 equals 5, 7 equals 7. That means they're the same line, and there are infinitely many solutions. Okay, so let's start by solving by graphing. Okay, so if we want to graph these two lines, they're already in slope-intercept form. They're already in the form y equals mx plus b. So let's go ahead and graph those two. So the top one, y equals 4x plus 4. I'm going to start at positive 4 because that's my y-intercept, and my slope is 4 over 1, which means I could go up 4 and to the right one. However, if you notice, I can't go up 4 on my graph because I would go off of my graph, which also means I can go negative over negative, so I can go down 1, 2, 3, 4, back 1, 1, 2, 3, 4, and back 1. And we can connect those lines here. See how good I can do that. If I can connect my dots, there we go. And then my second line here, 1/2 x minus 3. I'm going to start at negative 3. And my line, my slope, excuse me, is 1 over 2, which means I can go up 1 and over 2, up 1 and over 2. Or I can go two negatives, which is down 1, back 2, down 1, back 2. And if you notice, these lines intersect at a single point right here. And our solution is going to be that ordered pair. So our solution is going to be the ordered pair negative 2, negative 4. So that is our solution. The graph is our work that we show. Our solution is actually the ordered pair. So then let's come over here and look at this graph. So we've got y equals negative 5x minus 2 and y equals negative x plus 2. So our first graph, I'm going to start at negative 2. Okay, and my slope is negative 5 over 1. So if you look at my graph, I can't go down 5 first because I'd be off of the graph, which means I can also go up 5 and back 1. So I can go 1, 2, 3, 4, 5, and back 1. And that's as many points as I can get on this particular graph. So let's go ahead and draw in that line. Again, it's not super straight. And then my second graph is negative x plus 2. So I would start at positive 2, and my slope is negative 1 over 1, which means I'm going down 1 back, or to the right 1, or I can go up and back, up and back. And if you notice, my lines here intersect at this nice ordered pair right here, and that ordered pair is negative 1, 3. So my solution, again, is that ordered pair. So when we're graphing, we can just look, and for the purpose of what we're going to do today, all of our ordered pairs on the graphs should be on the coordinate plane that you are given, and they should be nice, neat ordered pairs, so there shouldn't be any fractions or decimals. The second way that we are going to talk about how to solve is by substitution. This is algebraic. You're not actually going to do any graphing or anything like that. You're going to substitute, which means substitution means you're going to take one thing out and put something else in its place, okay? So if you look here, we got substitution. In order to do substitution, one variable has to be already isolated by itself. So right here, I have got y equals negative 3x plus 4, which means anywhere in that top equation that I see a y, I can take it out. Oops. I can take that y out and put negative 3x plus 4 in its place. Okay, what that does is that creates one equation with one variable. So I am going to use this first equation. I'm going to take y out and I'm going to put negative 3x plus 4 in its place. So watch carefully. I'm going to say 2x, that top equation, minus, let's erase that so we can actually see that a little bit better here, minus 4, and instead of y, I'm going to put that negative 3x plus 4 equals 12. So again, all that we did here is we took out the y and we put in negative 3x plus 4 in its place. There we go. My eraser was not wanting. So we put that in for that. Okay, so then we're just going to do a little bit of algebra. We're going to have to do some distributing. So I'm going to have 2x. Negative 4 times negative 3 is 12x. Negative 4 times positive 4 is negative 16 equals 12. Okay, so we've got some like terms here. I've got 14x minus 16 equals 12. If I add 16 to both sides, I get 14x equals 28, so x equals 2. But if you remember, our solution is an ordered pair, which means we need an x and we need a y. So I am going to go all the way back up to the top up here. I'm going to pick one of my equations. In this case, I'm going to use this bottom one, y equals negative 3x plus 4, because now I'm going to, anywhere I see in that equation, I see an x, I'm going to put 2 in its place. So I'm going to use this equation, and I'm going to say y equals negative 3. Instead of x, I know that's 2, so I'm going to say 2 plus 4. So I'm going to say y equals negative 6. Negative 3 times 2 is negative 6 plus 4, so y equals negative 2. Which means my solution, gosh, I'm way down here on my page, but my solution is my x is 2, my y is negative 2. So I still have an ordered pair for a solution. Okay. And then go ahead and pause the video here. I want you to try this one on your own, substitution, and then you can go ahead and check with it with the video when you're done. So pause the video, try this one just like we did the last one, and you should get a nice, neat ordered pair, and then start the video again, and I have the solution for you to check it with. Okay, so take a minute, check your work here and see where you're at. Make sure you got negative 4, 6 for this solution. If not, go back and try to see where you made your mistake, or you can ask for assistance. Okay, we're going to do 2 more with substitution here. And if you notice, these equations are a little bit different because one is not already solved for y, right? So I've got 4x and 4y equals 8, x plus 5y equals 4. Neither one of these is solved yet for x or y. So I look at my options here. If I want to have one of my variables by itself, I'm going to use this second equation because I can easily get x by itself. So to get x by itself, I'm just going to subtract 5y from both sides, and I get x equals negative 5y plus 4. Which means anywhere in my first equation that I have an x, I can take it out and I can put negative 5y plus 4 in its place. So let's go ahead and do that. So we're going to say 4 times negative 5y plus 4 minus 4y equals negative 8. Or excuse me, negative 8. I wrote negative 18 there. Sorry, negative 8. And then do our algebra here. So we're going to distribute negative 20y plus 16 minus 4y equals negative 8. Combine our like terms, we get negative 24y plus 16 equals negative 8. Again, those were our like terms right here. And then I'm going to subtract 16 from both sides, and I get negative 24y equals negative 24, which means if I divide both sides by negative 24, I get y equals 1, which is nice. We have half of the problem done now. So now that I know what y is, I'm going to come back up here, and I'm actually going to use this equation because I need x, and in this equation, x is already by itself. So I'm going to say x equals, and instead of y, I'm going to put 1. So x is going to equal negative 5 plus 4, which is negative 1. So just be careful with your x and y's, because if you notice on this one I solved for x first to find my y value. So my ordered pair is going to be negative 1, 1. Okay, so just like on the last slide, I'm going to do the same thing. I'm going to have you pause the video. I want you to try number 7 by yourself and see if you can get the same answer. When you start the video again, I'm going to have the solution worked out on there for you. Okay, did you happen to notice here when you worked this one out that the x's canceled out and all you ended up with was a true statement at the end? If it is a true statement at the end, that means there are infinitely many solutions. And that actually technically means if you graphed it, it would actually be the same line. Okay, so now let's look at some how you can use elimination. The name elimination basically means you are eliminating or getting rid of one of the variables. And if you look, what our goal is to have one of the variables have the same coefficient, opposite signs. So I started out nice and simple with these because if you notice here, the y's, there's a negative 7y and a positive 7y. And what we are going to do is combine our two equations together. So we are basically just going to add our equations together. And what happens is when you add 7x minus 4y, you end up at 3x. Your y's actually end up canceling, and you get negative 12 when you add negative 7 plus negative 5. So if you divide both sides by 3, you get x equals negative 4. That works out pretty well. If you look at these, it's not easy to just pick which one you want to substitute the x back into. I usually try to pick one with smaller numbers or more positives. In this case, it really doesn't matter. So I'm just going to go ahead and substitute into that second equation. So I'm going to say negative 4 times negative 4, because that's what x is, plus 7y equals negative 5. So I got negative 16 plus 7y equals negative 5. If I add 16, oh, that should be positive 16 right here, sorry. That should be positive 16, which means we are not going to add 16 to both sides. We are going to subtract 16 from both sides, sorry about that. And we're going to have 7y equals negative 21, y equals negative 3. Okay, so our ordered pair, our solution, again, is not just our work here. Our solution is negative 4, negative 3. That's our solution. Okay, so again, go ahead, pause the video just like we did before and try number 9. Okay, so here we are. If you did it correctly, you should have ended up at negative 3, 2. So go back, look at your work. If you didn't get the same answer, feel free to ask or see if you can find the mistake that you might have made. Now we go one step just a little bit more difficult. Get rid of that little line right there. Where if you look, our x's are not going to easily cancel, and our y's are not going to easily cancel either, which means we are going to have to manipulate our equations so that they will eliminate. So we want to think, okay, I want my coefficients to be the same number, one positive and one negative. Well, if I'm looking at my equations, I have a 2 and a 6. That's not going to be super easy to get both of them to be the same. Well, you could. Or you have negative 5 and 1. So our goal here is we either want the x's to be positive 6 and negative 6, or we want our y coefficients to be negative 5 and positive 5. So let's think about which one we want to do, because it really doesn't matter. I am going to eliminate the y's because I think that looks easier to me. So if I want to eliminate the y's, that means that my equation on the first one, my y coefficient needs to be 5. So that means I'm going to multiply both sides of the equation by the same thing. I'm going to multiply it by 5 because that's going to give me a coefficient of 5 there. When I distribute, I'm going to write my new equation here, 5 through there, I get 10x plus 5y equals 5 times 15, which is 75. Now I'm going to use this equation and this equation. I'm going to add them together. When I add them together, 10 plus 6, but I get 16x. My y's now will cancel, and I have 64. 75 minus 11. So if I divide both sides by 16, I get x equals 4. Now, if I want to figure out what y is, I can use any one of those original equations up there. I am going to actually use this equation right here because it has y all by it has y with no coefficient on it, so that's why I'm going to choose that one. So I'm going to use this equation, and I'm going to put 4 in for x. So I'm going to say 2 times 4 plus y equals 15. I get 8 plus y equals 15, and our y is going to equal 7. So our ordered pair is 4, 7 for our solution. Okay, I want you, just like before, I want you to try this one and see what you come up with. Pause the video, think about which equation you want to multiply through by to eliminate either the x or the y. You can do either one, it does not matter. Okay, so think about it and solve it and then see if you agree with what I have. Okay, would you look at that? It was another one of those tricky ones. Your x's all canceled and your y's all canceled, which means you ended up with an untrue statement when you were done. If it's an untrue statement, that means that there is no solution. Okay, so here is our last example. I know this is a lot of information in one lesson video, but here's our last example. Now, if we look, this one's not going to be quite so easy, right? Because I have 7x and 5x. I've got 5y and 3y. I can't just easily multiply one equation by something. I actually have to multiply both equations by something. So if you think about, if I want my x's, say I want to eliminate my x's. We could do either one, but I'm going to eliminate my x's. That means I need to have my coefficient of my x be positive value and negative value of the same positive value and same negative value. So if I look at 7 and 5, I'm thinking about my least common multiple. And the least common multiple, like if I started counting by 7s and I started counting by 5s, my least common multiple would be 35. So what I'm going to do is I'm going to multiply my top equation by -5. Now, why did I multiply by -5? Because that's going to give me a -35x. You have to multiply everything in there. Minus 25y equals -45. So now I have a -35, which is all fine and dandy, but now I have to do something with this second equation. If I have -35 in my top equation, I want my bottom equation to have a +35. So I'm going to multiply everything in the bottom by +7, which is going to give me a +35x, a +21y, and a +21. Now when I put them together, if you notice, my x's will cancel. And then I've got -25 and +21. I'm going to have -4y equals -24. If I divide both sides by -4, I get y equals 6. Now I know what y is. I have to pay attention. I just found y. So I can go back up to one of these original equations, and I am just going to go ahead and use, let's see, I'm going to use this top equation. It doesn't matter. I can use any of those equations up there that I want. I'm going to use that top equation, and I'm going to put 6 in for y. So I'm going to have, let's see here, I'm going to use this top equation. So I would have 7x plus 5, my y is 6, equals 9. Okay, so then we have 7x plus 30 equals 9. If I subtract 30 from both sides, I get 7x equals -21. -21. So my x value is going to equal -3. Okay, now I know what my x value is. I can take any equation that I want from up here. I can use the top equation if I want. So I'm going to pick a different color here. I'll use that top equation again, and I'm going to take out x, 7 times -3, because I know x equals -3, plus 5y equals 9. Okay, I got -21 plus 5y equals 9. If I add 21 to both sides, I get 5y equals 30, and my y value is going to equal 6. Just make sure you're paying attention to which variable you find first. So my solution is -3, 6. Okay, just like all the other ones, I want to go ahead. I want you to pause the video, and I'm just going to give you a hint here, right? I probably would not eliminate x's just because of the size of those numbers. I would probably go ahead and eliminate y's first. So we want to have one of the y's be a positive and one of the y's be a negative. And 7 and 4 are least common multiple. If we started counting by 7 and we started counting by 4, the first number we'd have in common would be 28. So we want to have a positive 28 and a negative 28. Okay, well, would you look at that? The ones here, looks like the questions on the right all like to be some of those special solutions, but if you notice on this example, still a good example for you to try on your own. You have the x's and they cancel, the y's and they cancel, the 28's cancel, and you get a true statement, 0 equals 0, which means there's infinitely many solutions. So go ahead, we're going to have some homework and work on this a little bit more again. So if you have any questions, just let me know.